Hello students, welcome back to my YouTube channel. Today we will discuss about the radius of the nth Bohr orbit. Okay, so that is we will be applying the Bohr postulates to find the radius of the nth Bohr orbit, and this is very important for your forthcoming examination, board examination. Okay, both ISC and CBSE students. Okay, so you must have a clear concept, crystal clear concept about this. So how to find the radius of the nth Bohr orbit? Okay, so let us first assume, suppose, so this is the radius of the nth Bohr orbit, so we consider it as Rn. Okay, so to find this, so let us first assume, suppose this is a nucleus. Okay, suppose this is a nucleus. Okay, and around this nucleus an electron is revolving. Okay, so electrons are revolving in a circular orbit around this nucleus. Okay, so these are the, suppose these are the electrons, which are revolving in this circular orbit, and this is the nucleus, and this is the average distance r between the nucleus and the electronic orbit. Okay, so for that, if there are n number of protons, in this nucleus, so what should be the charge of this nucleus? So that should be number of protons Z into electronic charge. So this is the charge of the nucleus. Okay, so therefore we can write that the electrostatic force of attraction, okay, Coulomb force, that is the Coulomb force of attraction between this nucleus and the electron, that is nothing but, we already know, 1 over 4 pi epsilon naught Jd q1 into q2, that is E, divided by distance square. Okay, so this would become 1 over 4 pi epsilon naught, so this is a constant, Jd square divided by r square, right? So F C, Coulomb force. Okay, so this is our equation number 1. Okay, now due to the circular motion of electron around the nucleus, so there must be a presence of centripetal force. So now the centripetal force, what should be the centripetal force? Centripetal force, that is nothing but, that is the mass of the electron into velocity square divided by distance between the center, that is nucleus, and electronic orbit. Okay, and this is the centripetal force. So we can say that during this circular motion, the centripetal force, okay, so this Coulomb force of attraction between nucleus and electron provides this centripetal force. This is very important concept. So we can write that 1 over 4 pi epsilon naught Z square by r square, this is the electrostatic attractive force. Okay, that should be equal to the centripetal force. Why these two forces are equal? Because this electrostatic force of attraction provides this centripetal force for this circular motion. Okay, so we can write from here that if we just cancel, so v r square cancel, so simply the v square, that is equal to nothing but z e square, that should be z e square. So if you just simplify this, that should be 4 pi epsilon naught into m into r. Okay, so that will be our radius, sorry, this will be our velocity square. Okay, z square by 4 pi epsilon naught r. Again by using the Bohr's quantum condition, that is the third postulate. What is the third postulate? That is the orbital angular momentum of electron in any orbit or in any stationary orbit, that is h over 2 pi, integer multiple of h by 2 pi, that is L is equal to nh by 2 pi. Okay, so this is the Bohr quantum conditions regarding the angular momentum. So that should be written as n is equal n into h cut. What is h cut here? H cut is a new physical quantity which is taken as h over 2 pi. So you can also write this in terms of h cut. In few books you will see that this derivation is in terms of h over 2 pi, but you can also use h cut, but you must have to mention h cut equal to h over 2 pi. Okay, so that means L, so L is the angular momentum, so we can write it as mvr is equal to nh cut. So v is equal to nh cut divided by mr, so v square, that should be n square h cut square by m square into r square. So suppose this is our equation number 4. Okay, now just combine these two equations, equate equation number 3 and equation number 4. So therefore equating 3 and 4, from 3 and 4 we can find that z square divided by 4 pi epsilon naught into mr, that is equal to n square h cut square by m square into r square, right? So just we can just simplify, so r square cancel, m square cancel, right? So 1 over 4 pi epsilon naught z square, okay, divided by 1 is equal to n square h cut square by mr. Okay, so from there we can find the expression of r. So what should be the expression of r? So r should be simply 4 pi epsilon naught n square h cut square by z square into m. 4 pi epsilon naught n square h cut square by z e square into m. So this is the radius expression of nth orbital electron. Okay, so nth Bohr orbit. So this is the expression of nth Bohr orbit radius. Now from this equation we have to understand a very important concept. Okay, so what is the concept? The concept is that it is clear that Rn is proportional to n square divided by z. So you must have to remember this relation, Rn proportional to n square divided by z. That means as n increases, if n increases, so the radius also increase. Okay, in the power of 2, at the power of 2. And so this is for hydrogen like atom, not for hydrogen atom. Okay, so if we apply for H atom, so for hydrogen atom, what is the value of atomic number? So this is z equal to 1. So we can write for hydrogen atom r proportional to n square. And this question is very important. So in your examination this was asked, sometime it is asked that prove that or show that the radius of nth orbit is proportional to the square of the principal quantum number. Okay, so you have to prove this. Okay, so that means we say that the radius of the first orbit is to radius of the second orbit is to radius of the third orbit is like dot 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 up to, so what is the first orbit? This is 1 is to second for n equal to 2, so 2 square means 4 is to third, for third orbit n equals to 3, so 3 square means 9 is to 16, like this. So these are the ratios. So these are the ratios between different orbit, first orbit, second orbit, third orbit and fourth orbit and so on up to nth orbit. Okay, so if we just want to draw, so suppose this is our nucleus, positive nucleus. So if this is first Bohr orbit n equal to 1, so the second one will be at a 4 times larger. So 4 times larger means you must have to know how to draw this. So suppose this is our 4 times larger, so this will be n equals to 2, not the same distance from the nucleus. So this distance is much more than this distance, and that should be 4 times. And for third this should be 9 times, that means like this. Okay, so n equal to 3. So you have to draw in this way, the radius of the different orbit you have to draw in this way. Okay, so this is our nucleus. Okay, so I hope all of you understood what is the relation between the different Bohr orbits, radius of the different Bohr orbit, and how to find the nth Bohr orbit radius. And this relation is very very important, and you have to remember how the nth orbit radius varies as principal quantum number. Okay, so basically questions frame from this portion. Okay, so that's it for today. In next class I will discuss about the energy. I will discuss about the total energy of nth orbital electron. Okay, so thank you all. So and so please subscribe my channel, so I will get motivated to upload more videos regarding this topic. Okay, thank you.